Yes, class. Good evening. Is this audible?
Good evening, ma'am.
Akifa, how are you? Where were you? All well? Akifa? All right. Fine. So in the last class, we had basically seen the motion of a charged particle. How a charged particle moves into the magnetic field. Now, we didn't start with Lorentz force exactly. What is Lorentz force? So in today's class, we'll actually study what is Lorentz force. See, for understanding Lorentz force, you have completed the major portion in the previous class. When you remember, we had calculated magnetic force. Magnetic force was what? Basically, magnetic force was charge that was multiplied by the cross product of velocity and electric field. So velocity and magnetic field. We had seen a Q, V cross V. So that is the magnetic force. And electric force also we have already studied. Electric force is QE, that is charge multiplied by the electric field. So Lorentz force is basically if you put a charged particle which is having electric field and magnetic field. We have done both these fields separately. When we put the charged particle in electric field, the force that we get is, this is Lorentz force. See, when we put the charge in electric field, we get the force as Q multiplied by E. This is the force that we get. When we put the charge in magnetic field, so the magnetic force that we get is Q V cross B. Now, Lorentz force says, what if both the fields exist simultaneously? Like electric field is also there and magnetic field is also there. Then which formula you would use? Whether electric field you should use or magnetic field you should use. So in this case, when you have electric field and magnetic field both present, the net force that will be given by the sum of both the forces. It means electric force will also act and magnetic force will also act. So I'll write down the definition of first of Lorentz force. It says if a charged particle is moving in a region that is having both the fields, having both electric and magnetic field. Then what happens to the charged particle? Charge may experience, then charge may experience both electric as well as magnetic force. Both electric and magnetic force. Both the forces will come into action. Now, how will you write it? So basically, it will be the net force will be the sum of both the forces. That is, F net can be written as Fe plus Fb. So this becomes QE plus Q into V cross B. Both the things you can write. This will be the net force. This will be due to the electric field. This will be due to the magnetic field. So if we take charged particle common, we will be left with E plus V cross B. That becomes the net force, and this force is known as Lorentz force. The name of this force is known as Lorentz force. So whenever Lorentz force term is mentioned, so you have to use both of these forces. So when to know that when you have to utilize Lorentz force, you can easily identify when you see that magnetic field as well as electric field, both are mentioned. So when both the fields are mentioned, you can directly use this formula. If only one has to be used, then only magnetic field or electric field would be provided. So according to that, you can put it. Now regarding the direction, as you know, force is a vector quantity, so the magnitude you can calculate using this formula. But what about the direction? So electric field, I hope you people remember. If not, let's just revise it quickly. In case of electric field, if let's say, just make it a note point and write it. Firstly, write it for electric field. So direction of electric force. So see, let's say electric field lines are in this direction for a positive charge. This is the direction of electric field. What should be the direction of this positive charge? Who remembers? We have done this in electrostatics.
Towards the electric field.
Towards the electric field, yes, right. For a positive charge particle, it will be towards the electric field. Good for you. Now, if it's a negative charge, then it will be the opposite direction. If this is the direction of electric field, if this is a negative charge, then force occurs in the opposite direction. So electric field's direction you people know. And in the last class, we had studied the direction of magnetic force. Remember, magnetic force we had seen. Place your hand in the direction of velocity, curl your fingers towards the magnetic field, and then the thumb gives you the direction of magnetic force. So by that right hand thumb rule, you can calculate the direction of magnetic force. This is given by right hand thumb rule. So using this, you can find out. Now, we haven't done any question based on Cartesian form. Whenever we have been using cross product, remember, tau also used, P cross E, P sine theta came, and many things we have already used. But we haven't done it in Cartesian form, because when two vectors are cross multiplied in Cartesian form means I cap, J cap, K cap in terms of this. Like force is I cap minus 2 J cap Newton in this manner. So this is known as Cartesian form. In 11th standard, I think you people must have studied it when you would have done your vectors and everything. There we study polar form, Cartesian form, all these form. So when angle is given, that is the polar form. When I cap, J cap, all these terms are given, then we call it as the Cartesian form. So in Cartesian form, you have to form the determinant system and then take out the cross product. So let's just practice a question on that. But before that, note down these few points on Lorentz force. Then we'll do a question on cross product. Any answers coming, or should I discuss it now? I haven't received any answer yet. Okay, let's discuss it. See, velocity is given to you. Instead of giving the terms in direct magnitude with the unit, they have given you in terms of Cartesian form. Like velocity is given as I cap minus 2j cap. So velocity is I cap minus 2j cap meter per second. Just add meter per second in the question. Electric field is given 2I cap minus 3j cap, and magnetic field is given I cap minus j cap minus 5k. Now, all those who don't remember this, how to solve vectors in Cartesian form, just look at this carefully, how to solve it. Firstly, if we find V cross B, this is only the cross product. Rest of the things are adding and simple multiplication, so that we can do later on. First, let us find out the value of this V cross B. If you know the value of this V cross B, then you will be able to easily get your answers. So this is V cross B. So let's just write all the Cartesian form first. So I cap, then J cap, then K cap in this manner. So this is I cap, this is J cap, and this is K cap. So first, which the vector are we putting? V. Don't ever reverse the order. If it is given you to you as V cross B, then write your answer as V first and then V. Don't interchange it like B cross B. Don't make it. If it's given in the formula V cross B, then use the first vector first, because as we have discussed, as you change the vectors, I cap cross J cap gives you K cap, but J cap cross I cap gives you minus K cap. So everything gets changed. That's it. Fine. So V is what? V is given to us as I cap minus 2J cap. Whatever are the coefficients given, just put it. So first velocity, I's coefficient is 1. Coefficient of J is minus 2. Coefficient of K is 0 because no K is given. Then next vector is B. So I's coefficient is 1, coefficient of J is minus 1, coefficient of K cap is minus 5. This we have written. Now see how to get your answer. V cross B will be equal to, first put I cap. We will solve first it for I cap. So put it as I cap. Now we are considering which row? I cap's row. So ignore the row of I cap. The vector, the unit vector which you are considering, ignore that column and the row. Now whatever is left, what is left? These 4 will be left. Obviously, if you cross this row and cross that column and both the column and the row, then only these 4 will be left. So first multiply this, put a negative sign, and then multiply this. That's how we solve it. So how will we write it? We'll write this as, firstly, minus 2 into minus 5, minus 2 into minus 5, negative sign, and minus 1 into 0 is 0. So I cap column is solved. I cap is solved for us. But be careful when you reach on to J. When you write J cap, no, then already add a negative sign, minus J cap. Otherwise, you have to shift this order. So it's better you just add negative sign in advance so that this crossing portion remains uniform. Now what you have to do? This is the final force that you're getting, or just V cross B, Akifa? V cross B. Let's just check. I don't remember the answer. I think this is correct. First term is definitely correct, as we have seen. Okay, now we are considering what? We are considering J cap. For J cap, this column will definitely get eliminated, and which column now has to get eliminated? The J cap column.
J cap.
Now what is left? Multiply this and multiply this. So this becomes what? In this you have first minus 5 into 1 becomes minus 5 minus, and 1 into 0 is, then plus K cap you have. So for K cap, we'll be ignoring this column will definitely get ignored, and along with it, we have to ignore the K cap column. So this column will get eliminated and this column gets eliminated. So this gets multiplied by this and this gets multiplied by this with a negative sign in between. All those who had done it in 11th class, I hope it is getting revised, this Cartesian form unit vector solving. So what is it? Minus 1 into minus 1, minus 1 into plus 1, that is minus 1, minus 2 into 1 becomes minus 2. That's all we have. So we just have to now solve it. So this becomes what? Minus 2 into minus 5, that becomes 10. So this is 10 I cap. This is minus 5 into minus j cap, that becomes plus 5 j cap. Here we have 2 minus 1, that is k cap. Yes. So Akifa, what was your answer? 10 I cap plus 5 j cap plus k cap. Yes, right. Correct. Now see, you have what? You have V cross B with you. This is what? This is V cross B. What was our formula? Our formula said Q E plus V cross B. So electric field is what? Electric field is already given to you in the question. That is 2I cap minus 3j cap. So electric field is 2I cap minus 3j cap plus V cross B is what? 10I cap plus 5j cap plus k cap multiplied by the charge. So this becomes what? Q into 2I cap. So this becomes 12I cap minus 3j cap plus 5j cap plus 2j cap. K cap has nothing, so that becomes k cap. Charge is 2 coulombs given. So force becomes what? Force becomes 24I cap plus 4j cap plus 2 k cap. This much newtons will be your net force. And this force is known as Lorentz force. Fine. So just note it down. Any doubts in here? Is this line clear? This line. How to write this line? All of you. Clear or
Yes,
not?
ma'am.
Clear?
Yes, ma'am.
Just note down this. Question you people have written it, no? So, because Fatima, in case of J cap, we have to reverse it. Like first we start from this one and cross multiply along with this one, no? Like this we start. If we don't put minus in J cap, then we have to do it the opposite way. So many a times what happens, we forget to shift this pattern and our answer becomes incorrect. That's why in advance we are adding this minus J cap. Now, force on current carrying conductor in magnetic field. So we are right now considering only a single wire, a single current carrying conductor only. If two parallel conductors are placed beside each other, then we see that case differently because the formula gets changed. Right now, we are only focusing on a single conductor. Current carrying conductor is there. So a few things, let's just specify. Suppose let's say L is the length of this conductor. L is the length of the conductor. All right. A is the area of cross section. Area of cross section. So A is the area of cross section. What else? Let's say electron is flowing in this direction. So obviously current's direction will be the opposite. In this way, this becomes the flow of current. So I is what? I is the direction of current. Direction of current that is flowing within this. Now, let's say small n. Remember small n we did when we were discussing ampere circuit law. There we had seen the case of solenoid and toroid. There also we had seen small n was there. So small n had different meanings in case of solenoid and toroid. In case of solenoid, it was number of turns per unit length. In case of toroid, it was number of turns per unit length, but that became for a circle. So similarly, n has different meanings. Here we will be considering n as number density of electron. Number density of electrons. See, number density word we have used many a times. Normally also density means mass per unit volume. When we studied capacitor, there we had seen energy density. So that was energy per unit volume. Similarly, number density becomes number of electrons per unit volume. I'll write that as well. This becomes number of electrons per unit volume. This is meant by number density. Now, all the dimensions are given in front of you. Can anyone tell what will be the volume of this conductor? What will be the volume of this conductor?
LA.
LA. Atif? LA? Are you saying this?
Yes.
Correct. Yes, it will be L into A, means length of the conductor multiplied by the area. So that will be the volume of this. So volume becomes area into length. That is the volume. Now that is valid for a single electron. So for total electrons, what will be the volume? Total number of electrons in n volumes. So total number of electrons, that will become what? Number of electrons multiplied by the volume. So that gives throughout the complete length of the conductor. So we will simply multiply n with A. That gives the total number of electrons. So all these dimensions have been specified. Now regarding the force, we did that force, the magnetic force, Q V cross B. So here we are talking about electrons. Let me represent it through small f, because then the normal force that we are getting, F, that will be confusing. So right now I'm taking it as small f, but this is the same force that we had calculated, this force, Q V cross B. So instead of Q, I will write it as minus E. The charge is electronic charge, so I'll write it as minus E. V cross B, the velocity with which the electrons drift under the application of electric field. That is what? That is known as drift velocity. So instead of the normal velocity, I'll be mentioning the drift velocity and the magnetic field. It's just that in the main formula that we have studied, this formula, F is equal to FB is equal to Q V cross B. I have substituted all the values that are valid for this case. Fine. So again, the total number of electrons is what? NaL. So we have to multiply. This is a single electron. So the net force becomes NaLe. Minus sign will also be there. Vd cross B. All right. Now, can anyone tell what is this quantity? This. N into A into E into VD. What is this? No, not torque, something else. Yes,
Current?
current. Yes, Kulsum is also right, and I think Atif answered, no? Yes, current, NEAVD. Remember, we did this relation once we derived the formula for drift velocity. After that, we had derived the relation between current and drift velocity. So that is Fatima. I think it came in your question paper also, you were mentioning. So this is NEAVD. This is the current basically. So now in the main formula, I'll be replacing it. So the final formula becomes what? Instead of NEAVD, I can write the current. So now L cross B will be left. So L cross B will be left. Or which I can write it as, what trigonometric component comes when we open the cross product?
Sine.
Sine.
Sine comes. So we can write this force as ILB sine theta as well. So this is what? This is the magnetic force acting. Basically, this is your formula. From here, you can derive all these things. Basically, this is the magnetic force acting on current carrying wire. Now, what happens if two wires are placed? That case we'll discuss, but in between we'll do some numericals as well. Very, very short, easy numericals we'll do. Mainly magnitude and direction is asked from this. All right, so note down this as well. So what's the answer you people are getting? The calculation portion is very simple in this question. Magnetic field is given as 2 Tesla, current flowing is 5 amperes, 10 meter is the length, L is given, I is given, B is given. Cross means what? Inwards or outwards? Inwards. Cross means inwards. So the magnetic field is going inwards and the current carrying wire is placed like this. So both are making an angle of 90 degree. Magnetic field is going inwards. Look, you can take it as if magnetic field is going towards k cap, minus k cap, and the current is flowing towards I cap. So I cap and minus k cap means x axis and z axis make what kind of angle? 90 degree. So definitely sine 90 degree. You just had to calculate BIL. So F is equal to BIL sine 90 degree. B is 2, I is 5, L is 10, that becomes 100 Newton. Regarding the direction, we have already studied. Place your hand towards the, place your fingers towards the flow of current. So this is the flow of current and curl your fingers towards magnetic field. Curling towards magnetic field, thumb gives the direction of the force. So this becomes what? Force is upwards. Upwards, or I can say J cap. This becomes the answer. Okay, one more question I'm giving you people, but that you all should try in this manner. So any doubts in this part, ask me right now. But at least try it in the second one. So similar question to the previous one. Just try this one, at least all of you. Yes, Atif, right answer. Others also try. So only one student has tried. Others are responding. Sarah, Akifa, okay, fine, good. Yes, 100 Newton I cap is the correct answer, right? So 3 students have answered. Atif, Akifa, and Sarah. See, magnitude will remain the same. You need not calculate the magnitude again. Magnetic field is given as 2. Current is again 5 ampere. Everything, the whole data I have put in again. It's just that the position of conductor has changed and the position of the magnetic field lines has changed. Initially, magnetic field lines were entering. Right now, magnetic field lines are coming out of the plane. and current wire has been put like this. So this is the flow of, initially this was the direction of flow of current. Right now this becomes the direction of flow of current. If I keep my hand towards in this position, so magnetic field is where? Magnetic field is outwards. So I cannot curl it like this. I have to curl it outwards. So this gives the direction. The direction is what? When I curl this, this is the direction, that is I cap, or you can say rightwards, and magnitude will be the same. B into I into L. So magnetic force becomes what? B into I into L. That is again 100 Newton, but this time I cap, or you can write rightwards. Fine. So just go through all these topics. Let's just take a break of 5 minutes. So it's exactly 7:30 over here. At 7:35, according to my time, 5 minutes later, I'll start the class. So let's take a break over here. Stay connected. Whatever doubts you're facing, note down this portion. When any doubts, if you people have, ask me. I'll be clearing. Fine. And after 5 minutes, we'll start with the next topic. All right, class. So we had completed for a single wire. I hope everyone is here right now. Now, if two long parallel wires are there, so what will be the magnetic force? So that this derivation is very easy, and this comes in your exam. The formula also comes, derivation also comes, and formula-based questions also come. Even in your NCERT back exercises, the questions from this have been mentioned. So practice that. But the derivation is very easy. It is not lengthy, and you people will be able to do it. Let's say these are two parallel wires, two long parallel wires, and this has the current I1 and this has the current I2. So this is the first one, this is the second one. Now we have to calculate what? We have to calculate the force. We are actually calculating what? We are calculating the force between two long parallel current carrying wires. So two long parallel current carrying wires we are considering. Now, whenever you start the derivation, because this derivation is short, so all these kinds of derivation which are short and easy, they come in the board exams. Lengthy derivations are sometimes not given, like dead drift velocity one, but that can also come. Anything can come, so be prepared for that. But right now, we are calculating what? We are calculating the force, yes. So you have to take two long conductors. So we have taken two long conductors with a separation. Let's say small d is the separation between them. Conductors with separation small d between them. This is the separation between them. Now force, we are actually calculating the force on this second conductor due to this first one. Two conductors are there, first conductor is there, second conductor is there. Force we are calculating not somewhere in between, we are calculating the force on the second one due to the first one. I'll write down that as well. Force on two due to one. We are actually calculating this right now. So for calculation of the force on the second one, no, the magnetic field will be produced by the first one, the first conductor. So if this is a conductor, just imagine this is just a conductor, and at this point you have to find out the magnetic field. So what should be the formula? We have done so many cases. Circular wire we have considered, finite wire we have considered, infinite wires we have considered. Distance. At this point, if you are asked to write, what will be the formula? B is equal to mu naught I divided by 2 pi d. That was the formula of magnetic field. Forgotten? Just go back through your notes and revise it once. All right, so magnetic field due to the first one, that becomes B is equal to mu naught I1 by I1, because we are calculating the current due to the first conductor. So magnetic field will also be for that one, divided by 2 pi d, because d is the separation that we are taking. So B1 that we have. Now force on the second one due to the first one becomes what? ILB we have ILB sine theta, ILB sine, so sine theta obviously 90 degree, because magnetic field we are considering the length of the conductor, and magnetic field we are taking it as inside. So even using your right hand thumb rule, if you apply, magnetic field will come out to be perpendicular. Now current will be on the second wire. We are calculating the current on the second wire. Length also will be, both the wires have the same length, but a magnetic field will be due to the first one. So put in the value of magnetic field in this formula. What will it become? F21 will become I2 mu naught I1 divided by 2 pi d into L. So let me write it properly. This becomes mu naught I1 I2 L divided by 2 pi. This is the force on the second conductor due to the first one. Now, if I shift this length on this left hand side into the denominator, this small l, if I shift it here, it becomes F21 divided by L. Let me write it as small f21. This means what? This is force per unit length. This is the force per unit length. So I'm writing it as F21. So F21 will be what? Mu naught I1 I2 divided by 2 pi d. Just eliminate this L from here. We have just put in L here. Why are we writing this? Because most of the time in questions, force per unit length is asked. It can happen that length will be given to you and force can be directly asked, but most of the times force per unit length is asked. That time don't put in the value of length again in the formula, because that is assumed that the force gets divided in the length. So this is what? This is force per unit length on second conductor due to the first one. Fine. If it is asked what is the force on the first conductor due to the second one, opposite if it is asked. So remember, F21 will be negative of F12. So whatever answer you're getting, just reverse it for the other one if you have taken it. Regarding the direction, remember, if both the conductors are having the current moving in the same direction like this, both the conductors are there, the currents are moving like this or the currents are moving like this. Currents are moving in same direction. Then remember, both these parallel conductors will attract each other. Be the currents flowing downward, be the current flowing upward, both should be in the same direction. They will attract each other. So conductors attract. And if it is either upwards or downwards like this, so that means current are moving in opposite direction, conductors repel each other. This is the form. Now, one more thing that comes in it to define 1 ampere. So if it comes to define 1 ampere using force per unit, if it mentions you in the exam that using the force between two parallel conductors, define 1 ampere. If under this heading you are asked to define 1 ampere, otherwise 1 ampere could be defined as the amount of charge, 1 coulomb of charge that flows in 1 second. But if it doesn't mention anything else, if it only mentions you specifically that force between two parallel conductors, long wires are given, and you have to define 1 ampere, then what you can do, force per unit length is what? F21 came out to be mu naught I1 I2 divided by 2 pi d. We have to define 1 ampere. If we put I1 I2 as 1 ampere, small d also as 1 ampere. So see, that will leave us with force as 4 pi, no, 4 pi into 10 to the power minus 7. 4 pi into 10 to the power minus 7. Currents are 1, 2 pi, d is also 1. So force is 2 into 10 to the power minus 7, this much Newton. Now, how can we define 1 ampere? 1 ampere is basically the amount of current that flows. We are defining 1 ampere. See, I'll write it. 1 ampere is the current when flowing through two long conductors. 1 ampere is what? 1 ampere is the current that is flowing. This part. We have just written this part only. 1 ampere is the current flowing through two long conductors. Now let's write this part. Means separated by 1 meter. Separated by 1 meter. Can attract or repel each other? We'll mention that. Give what amount of force? This part is left to be written. So gives 2 into 10 to the power minus 7 Newton of force. And one more thing also, that and can attract or repel each other. They can attract each other or they can repel each other. Now, when they attract, when they repel, the condition you people know. So note down things and we'll do questions on this.
फिर carpet पे सोएंगे।
Fatima, your mic is on. Now see, force per unit length if we calculate. So force divided by length, that the formula without the length. Okay, someone has calculated. Kifa, F21 is coming 10 to the power minus 6. 10 to the power minus 6. Something else will also come. Let's see. See, this is mu naught I1, I2 divided by 2 pi d. Mu naught is 4 pi into 10 to the power minus 7. I1 is 2, I2 is 10. This is 2 pi, d is also 2. So 2 gets cancelled. Here it becomes 2. So see, Akifa, this 2 will also come. The rest answer was fine. This becomes 10 to the power minus 6 multiplied with this 2 as well. Fine, this much newtons. Now regarding the direction, we are calculating the force on the second one due to the first one. It means we have to see the motion of the second one. So the second one will get attracted towards it. So it means it will move towards the left hand side. That is minus I cap, because we are just seeing the motion. And since both the charges are pointing towards the same direction, it means they will attract each other. So that shows that 10 ampere one means the second one will move towards the first one. So we'll write it as minus I cap. Second one, you don't need to calculate. This was F21. So F12 will be negative of F21. So F12 becomes minus 2 into 10 to the power minus 6 Newton, and it will move towards right hand side, towards the second conductor. That becomes only I cap. This much. All right, note down the solution. Let's do one more question on this.
Ma'am, can you explain again how you got minus I cap?
Minus I cap in the first one. See, we are just, both of them will attract. That you agree, Krishna?
Yes, ma'am.
So it means both of them will move like this. Attraction is this only, both of them will move like this. First part is asking you what? First part is asking you force per unit length on conductor second. So you just have to tell the motion of the second conductor. Because obviously net force you are not calculating right now. No, that you will say both of them will attract each other. Second one is going where? Right or left?
Right?
Second one is going right.
Oh no, left.
Left, no? That becomes minus I. This. If it
Okay, ma'am.
asks you for first one, then just look at the motion of the first one. If both of them are repelling by chance, let's say 10 ampere, one is going downwards, both of them are repelling each other. So this becomes plus I cap. In this way, you have to write it.
Okay, ma'am.
Written the solution of the first question. Let's do the second question. See, this is a wire given to you. and a rectangular loop of coil is given. So I2 is current flowing in the wire and I1 current is flowing in this rectangular loop. So obviously each segment will have the current I1. A segment, let's name the segment A, B, C, D. So AB will have a force. Okay. See, just look at the segment AB and this current wire having a current I2. Will AB move towards I2 or away from I2? Towards it, because both are in the same direction. So obviously it will attract it. So this becomes direction of FAB. All right. Force on this is FBC. Similarly, force on this is FCD, and the force on this segment, this is FAD. All the forces are here. Now, if you look at this carefully, FBC and FAD, they are at the same separation. We are calculating both the forces are at the same separation. Means whatever magnitude, we are not even calculating that. Why? Because whatever is the magnitude of FBC, that will be the same magnitude of FAD. So net force on this becomes FAB plus FBC plus FCD plus FDA. Now, if you look at all the forces, BC and AD, both of these will cancel each other, but FAB and FCD will not cancel each other. Though both AB and CD, both these forces are opposite to each other, making an angle of 180 degrees. But if you look carefully, the separation between FAB means the separation between AB segment and this is just D. Whereas the separation with this CD segment and this current, this whole is complete, D plus L, this much length. Fine. So that's why both the forces do not cancel each other. Now we can write the magnitude. If you just look at the first one, FAB, look just at FAB. So current is 1. This is current I2. This is I1. So FAB becomes mu naught I1, I2. Force per unit length we'll calculate. Okay, no, force per unit length has not been mentioned. So we are calculating the force. So length, can anyone tell what is the length AB by looking at the figure?
B.
B. The length, this length is B. This is B. Because this is B, this is a rectangle, regular rectangle. So instead of the length, we have B divided by 2 pi D. Direction, it will be attracting. We can see the direction, FAB. So this will obviously be minus I plus FCD. See, everything will be the same for FCD apart from the direction and the separation. So here we'll have mu naught I1, I2B divided by 2 pi D plus L here we'll write because this whole separation is D plus L and direction will be I cap. So this becomes your complete answer. All right, note down this is All right. Now, see, we have to calculate now current carrying coil as a magnetic dipole. This means what? This means that current carrying coil, which is acting now as a dipole. Dipole is what? We have studied dipole. Dipole is two opposite charges which are having the same magnitude. Now, in case of magnetic dipole, what does it become? In case of magnetic dipole, it means a south polarity and north polarity. Now, how to identify the direction? That is very easy to identify. If let's say the current that is moving here is in this direction, so and the current moving here is in this direction. Now whether it is south polarity or north polarity, this is the last topic. I'll wind up after this. Just go along with it. If you draw an S and see the edges, both are same, this means this has south polarity, so that becomes easier to remember. Now if you draw south polarity for here, both of them are not matching, both are going in opposite direction, it definitely means this is not south polarity. So only south polarity will match for this case. If you write n in this manner, this is given I think in the NCERT also, this becomes north polarity. So this is an easy way to remember. Now one formula that you have to remember for magnetic dipole is M, which is equal to NIA. This formula. I'll show you how questions we use it. We'll do a very simple question today. M is the magnetic dipole moment. N is number of turns of the coil. I is the current in the coil. And A is the area of the coil. Any shape coil can be given to you. We'll do two shapes today to see it. And the direction, how to calculate the direction. Direction of magnetic dipole is given by right hand thumb rule again, because as I've told you, not to get confused with other rules, we'll be just focusing on right hand. So with the right hand. So again, we have done this. I'm just reminding you. Move your fingers along the sense of current. So curl your fingers after the right hand along the current, and the thumb gives you the direction of magnetic field. Like for clockwise, this becomes the direction. For anti-clockwise, this becomes direction. Like this. We have already done this. So in this, I'll write down the direction once again. Direction is basically curl your fingers along the sense of current. Thumb gives direction of not magnetic field, magnetic moment. So it's the direction is same as that of magnetic field. The direction of magnetic moment, this is same as that of magnetic field. So before doing the questions, I think you write these points first, then I'll give you the question. See, like this question. Different figures could be given. A circular loop is given, a square loop is given, a rectangular loop could be given, even 3D figures could be given. So let's do with the simplest one. Magnetic moment is what? NIA. So N is basically 100. Number of turns is not 1 given here. It is given 100. So N will be 100 into current into pi r square, the area. So that becomes 100 into 2 into pi r square will be 1 square. Radius is 1 meters. So this becomes what? 200 pi. And see, this is moving clockwise. So curl your fingers clockwise, thumb is leading inwards. That becomes minus k cap. This much. Oh, unit also. Amperes meter square. Ampere is the SI unit for current and meter square for area. So this way. Then next, this was the answer for the first one. For the second one, magnetic moment is NIA. So N is 100, I is 2. Area of a square is side square, that is 2 into 2. This is 2 into 2. This becomes 800. And see, this is moving anti-clockwise. So that is outward. So that becomes K cap ampere meter square. Fine. So note it down. Any doubts in here, ask me. And just text me done when you people have completed the writing portion. One more class we require for this chapter. It's Thursday today, no? So on Tuesday, we'll most probably end this lesson. Conversion of that portion is left. Conversion of galvanometer into ammeter and voltmeter. That part is left. And 1 or 2 questions, obviously, of this topic. Fatima, Akifa, all right, done. Krishna, Sarah, all right. What about others? Others have also completed? Fine, so most of you have completed. All right, all those who have completed, you can leave the meeting. We'll meet in the next class, the last class for this lesson. Till the time, revise it, what all assignments you have pending, submit it. Yeah? Okay, take care. Bye-bye.
Thank you, teacher.
Thank you, ma'am.
Thank you.